very good morning to one and all. I'm Dr. Neeta, working as Assistant Professor at the Department of Zoology, Sacred Heart College, Chalapudi. And I'll be talking to you about evolution, which is a subject in the 5th semester of the degree course in Zoology. In this video, we look at Unit 4, that is Theories of Evolution as proposed by Lamarck and Darwin. We look into Lamarck's theory, his postulates, examples of how Lamarck tried to explain origin of life, and people who criticized Lamarck. And there were neo-Lamarckists who tried to explain Lamarck's postulates. Then we move on to Darwin's theory and his postulates, examples under Darwin's theory. Then we look at criticism against Darwin and neo-Darwinism. So in Unit 4 on theories of evolution, we talk about Lamarck and his theory and Darwin and his theory. So the period when Lamarck was there, when he proposed various postulates and tried to explain the origin of life, it was called Lamarckism. And during Darwin's time, it was called Darwinism. Now in this unit, you are expected to learn the following. You are supposed to know what Lamarck's theory is, what were the postulates of his theory, what were the criticisms against Lamarckism, and there were a new group of people who supported Lamarck and tried to give explanations, and these people were called the neo-Lamarckists. Similarly, you should know what Darwin's theory is, what were his postulates. There were criticisms against Darwin, and people who supported Darwin later called neo-Darwinists. Again, I would like to throw a question at you. Do you agree with Lamarck, or do you think Darwin is right? You justify your answer. So let's begin this unit with Lamarck's theory. Now, Jean-Baptiste Lamarck was a French naturalist, and he published his views in a book called Philosophie zoologique to explain organic evolution. According to him, there is a life force that guides organisms and enables them to overcome adverse environmental conditions. His theory is also called theory of the inheritance of acquired characteristics. Now, according to Lamarck, organisms pass on to the next generation characters that they acquire during their lifetime. So I've given you a picture of Lamarck here. Now, when you talk about the postulates of Lamarck's theory, he said nature always tends to enhance or increase the size and the efficiency of organisms or their components through some external environmental influence and some internal forces of life. So when is a new organ formed in an organism? A new organ is formed when there is a new need felt by the organism. And he also said when an organ is constantly used, it makes the organ better, more perfect, and shows maximum development. However, when an organ is not used, that is, it causes weakening, reduction or degeneration and ultimately disappearance. This is theory of use and disuse. Now, he also said that modifications that are acquired by an organism during its lifetime, an animal feels a need for an organ, it develops that organ, and that organ is inherited by the offspring. This is called the theory of inheritance of acquired characters. So he said cumulative modifications, additive modifications and adaptations over a period of time transform a species into a new one. So he said, to explain his theory, he said, look at wading birds. So wading birds are birds with long legs. So they need these long legs to stand in water. When they stood in water, they sustained a stretching of these legs over many generations, led to such long legs that you see in wading birds today. And he also said whales do not have hind limbs. Why? Because disuse of an organ will lead to its disappearance. So whales lost their hind limbs because of disuse. Another famous example that is often quoted when you talk about Lamarck are the example of giraffes. Now, according to him, the ancestors of giraffes had a short neck and short forelimbs. So when the surface vegetation became scanty, became less, they were forced to browse trees which are taller, higher. And they stretched their neck and their forelimbs, and that is why today giraffes have long necks and long forelimbs. So look at a picture of wading birds. See, they had to stand in water level. They stretched and stretched, and now they have long legs. Similarly, this is the ancestral giraffe with a short neck. When it had to reach for higher vegetation, it stretched its neck and neck became longer according to Lamarck. Now when you had listened to whatever I said, you might have had a lot of questions. This was the same thing that many people raised against Lamarck. So we will look at it under criticism against Lamarckism. Now when you say an organ with use increases in size, that does not always happen in nature. Sometimes an organ does not always increase in size. Also, formation of a new organ due to need. For example, if a man, he desires to fly or he has a situation wherein he has to fly, will wings grow out of him so that he can fly? And usually the constant use of an organism causes its wear and tear. Don't we chew our food every day, and don't older people have worn tooth? And therefore, the more you use an organ, wear and tear will reduce its efficiency in the long run. So inheritance of acquired characters, when you look at it from a genetic perspective, is not possible. An animal, which is an adult, if it has any modifications in its phenotype, it cannot pass on that modification to its offspring. So Lamarckism also only shows how a character can be improved. For example, the neck is there, it can only become longer. But how did that neck come about? So how a character is formed could not be explained by Lamarck. Also, another scientist called August Weismann, he proposed the germplasm theory and proved beyond doubt that acquired characters can never be inherited. He did an experiment. He took rats and he cut off their tails for many generations. You know that rats have a very short generation time. So he took a pair of rats, male and females, cut off their tails. He bred them, got their offspring, cut their tails, did this for many generations. According to Lamarck, the offspring should have shorter tails or no tails at all. But he never got tailless rats or stumpy-tailed rats, disproving Lamarck's theory of inheritance of acquired characters. He also differentiated body material into the somatoplasm and the germplasm. So he said environment can only affect the somatoplasm, and these somatic modifications are not inheritable, that is, do not go into the next generation. only changes that happen in the germplasm are heritable. But acquired characters are changes in the somatoplasm. So, such acquired characters are not heritable. So, look at this experiment where wise men took rats, he cut off their tails, but you can see the offspring, even after many generations, had long tails. Later, there were a few people who came about and supported Lamarck, and these scientists were called the neo-Lamarckists. They tried to explain Lamarck's postulates in a modified and an extended way. It tries to counter the objections that were raised against Lamarck's postulates. Now, according to neo-Lamarckists, genetic changes may be influenced by environmental factors, and certain acquired characters are inheritable. So, several neo-Lamarckists, they try to prove this through experiments. Presently, however, Lamarck's views are thought to be incomplete, but we can try to use Lamarck's postulates to understand influence of the environment on gene expression today. Now let us look at some of the experiments done by neo-Lamarckists. Camera, he took a pair of European salamanders with black skin and yellow patches, and he kept them in a box for 4 years. He kept one set in a yellow box, and after 4 years he found the yellow patches increased, forming thick yellow bands. The other set he kept in a black box, and he found them to be blacker with reduced yellow bands 4 years later. So another experiment he did, there were certain colorless blind cave-dwelling salamanders, and he bred them in bright light, and he found that they became colored from colorless, they turned black, and their eyes started functioning. So in the progeny, black skin and functioning eyes were seen, proving that acquired characters could be inherited. Look at this pair of salamanders, black and yellow salamanders. Those that were kept in a black box had larger black patches and reduced yellow ones, and those that were kept in a yellow box had reduced black patches and more of yellow patches. Sumner, he tried to prove Lamarck. He found that the body, the tail, and the hind limbs of mice, which were reared in warmer conditions, were longer than those reared in cold conditions, and he found that these characters could be inherited. McDougall, he did experiments on the inheritance of learning behavior. He took white rats, he put them in a water tank with 2 escape routes, one dark and the other lighted. But what he did was, he supplied the lighted route with electric shock. So through trial and error, the rats would go to the dark tunnel, the light tunnel, the lighted tunnel. When they come to the lighted tunnel, they would get an electric shock. Then they will learn, no, lighted tunnel means electric shock, you go to the dark tunnel. And so by trial and error, the rats were able to learn to avoid the lighted dangerous route. Now progeny of these mice, when they were subjected to the same test, it was found that there was progressive decrease in the learning time. That is, if the parents took 40 seconds to learn that the dark route is the best route, the offspring required only 20 seconds. So according to McDougall, learning behavior seems to be inherited. That is with Lamarck's theory. Then we move on to Darwin's theory. So now let us look at Darwin's theory. Charles Robert Darwin was an English naturalist come geologist who proposed the theory of natural selection. His conclusions were based on the observations on a 5 years long voyage on his ship, the HMS Beagle, to the Galapagos Islands, which is located about 750 kilometers away from the west coast of South America. There he studied all organisms, but in particular the finches and the giant tortoises. He was able to observe that there were 14 different species of finches on the 14 different islands. This is a picture of Darwin, and here we can see the giant tortoises that are found in the Galapagos. And these are the different species of finches that Darwin is able to identify. Now, before Darwin proposed his theory, he made a few assumptions. He said organisms undergo changes over time. These changes, according to him, are slow and gradual and take long periods of geological time, not a few years, not a few decades or even hundreds of years. They take about thousands and millions of years. And many organisms that lived in the past are extinct now. He also said that all related species are derived from a common ancestor by a process called evolutionary branching, which we today know as adaptive radiation. And he said the major mechanism, the major driving force behind evolution and speciation, that is formation of new species, is a process called natural selection. So natural forces that influence natural selection according to him are overproduction or prodigality of production. That is, any organism has an inherent ability to multiply exponentially. Why does this animal do this? In order to overcome the dangers of nature. So, an animal would produce, for example, a turtle will produce 100 and 150 eggs. Why? Because not all of them would survive to adulthood. He also believed in what is called differential reproduction of offspring. So, despite prodigality, that is, despite overproduction, despite the large number of eggs produced, the number of individuals of each species remains roughly constant. Why? Because many perish. Younger ones, they can need to survive. Only the surviving ones can reproduce. So, some in large numbers and some in small numbers. So, let me show you about two pictures of overproduction and differential production. Look at the number of eggs here laid by the turtle. These hatch, but when they go into the sea, other predators might eat them or they might not survive, and very few turtles are seen in the environment. So this is an example of overproduction. Why does this turtle produce so many eggs? He wants to make sure that at least a few survive. Now, what is differential reproduction? When you look at this dog, it has a litter, and in all these dogs, this tiny one is not able to reach the milk from the mother. So this tiniest dog in the litter has reduced differential reproductive success because it doesn't feed, it is not robust enough to maybe grow and survive. Another aspect that Darwin believed was struggle for existence. He believed that there is competition among organisms of the same species or between species for space, for shelter, for food and mates. And he said there are three kinds of struggles: intraspecific, that is competition between members of the same or closely related species where their needs are the same. Their food is the same, the kind of shelter they need is the same, the mates are the same. Another type of struggle is interspecific struggle, which was between members of different species when their niches overlap. This would result in the extinction of the weaker species. Another struggle which all species undergo is the struggle with the environment. That is, the environment throws at them unfavourable conditions with which they have to struggle and overcome to survive. Let me give you some examples of intraspecific struggle. You can see these fighting going on between the deer, the bear, and between prawns. And here you can see interspecific struggle. A lioness has felled a zebra, and you can see there are hyenas and vultures trying to get at the zebra as well. So this is where different species of animals struggle under interspecific struggle. When you look at struggle with the environment, here you can see there are a lot of animals trying to cross the river, trying to find better pasture. This happens in the Serengeti when you have the dry season. These animals, the wildebeests and the zebras, they try to cross the rivers and go to better feeding locations. But what happens in between? There are crocodiles. They try to eat these zebras, fell these zebras, and they have to struggle with this to get across. So that's about struggle, interspecific, intraspecific, as well as struggle with the environment. Now, according to Darwin, useful and heritable variations, that is, individuals which are variously modified, these variations could be neutral, of no use to the organism. It could be useful to the organism, or it could be harmful to the organism, but only useful variations, only variations that increase the fitness, that increase the survival value, or the evolutionary potentialities, only such useful variations are passed on to the next generation and therefore act as raw material for organic evolution. According to him, only the fittest survive. When there are any unfavourable variations, when the environmental conditions change, if any animal is not able to survive in such a condition, such an animal is eliminated. This is how he explained the longer neck length of giraffes. He said the environment changed, the scrub vegetation reduced, and giraffes had to reach out for vegetation on the trees. It was found that the giraffes with longer necks had a better advantage than giraffes with shorter necks. So giraffes with longer necks survived, and this character was passed on to the next generation. He also said that nature selects the organism, and this leads to the origin of species. So the favourable variations, the useful variations are selected by nature. The unfavourable ones, the useless ones, are rejected, and such favourable variations, when they accumulate over a period of time, lead to the formation of new species. I've given you photographs here of moth, Biston betularia, which we'll come to later, and mosquitoes which were resistant to DDT. Now, as in Lamarckism, there were a lot of people who criticized Darwin. Now, according to Darwin, all variations are heritable. But now we know only germinal variations are heritable. Now, Darwin was able to explain how the fittest survive, but he could not explain how the fittest arrives. He said the variations that happen in the animal are simple. they are small and they are continuous. So he was not able to explain discontinuous variations that we see in the world around us. Uh, Darwin could not explain heritable characters, how they were not diluted when they mingle, when they mate with other organisms which do not have this character, why it does not get diluted. He was also not able to explain the presence of certain vestigial characters. If these characters were not useful, why are they present? He also could not explain cladogenesis or branching speciation. He believed in anagenesis or phyletic gradualism. According to him, one species accumulates many changes over a long period of time. Small changes over a long period of time becomes a new species. That organism, after undergoing many small changes over a long period of time, becomes a new organism. He could not explain how one common ancestor could give rise to different species. And he was also not able to explain transitional species that were absent in many cases. If, according to Darwin, one species, after a long period of time, undergoing modifications, becomes a new species, if A modifies into B, B modifies into C, he wasn't able to explain why B doesn't exist. According to him, transitional species exist. Now, let us look at some examples of situations where Darwin's theory could explain how evolution happened. First, we look into industrial melanism. Now, there is this moth called Biston betularia, which is a peppered moth. When it rests on the barks of trees, the grey-colored betularia form, which was more abundant in the 19th century, when it rests on tree trunks which were then covered with white lichens, you could not see this grey-colored betularia. Whereas there were other forms, the dark-colored melanic forms, during this time as well. But the dark-colored melanic forms were at a disadvantage because when they rest on tree trunks covered with lichen, they stood out so much that they were easily eaten by predators. But after the Industrial Revolution started, there was a lot of soot coming out. The soot started covering the trees. Lichen could not grow anymore. And now what happened? The trees were now had dark bark. And on this, when the grey moths were resting, they were more easily noticed by the predatory birds, whereas the melanic form, which was at a disadvantage before the Industrial Revolution, was now at an advantage. These soot-colored trees were a perfect camouflage for the melanic forms. So we see that when the environment changed, only the fittest can survive. So look at this picture here. Before Industrial Revolution, here is the peppered moth. Wonder if you can see this. The peppered moth is here. You cannot see it against the lichen-covered bark of trees. But after Industrial Revolution, the lichen stopped growing because the soot started covering trees. It became darker. Now the peppered moth is easily seen, easy prey for the predators. The melanic form was easily camouflaged and it survived. A second example to Darwin's theory of natural selection is the resistance of mosquitoes to DDT. Now, in 1950s and 60s, because malaria and filaria were prevalent, in order to eradicate malaria and filaria, they found that mosquitoes were the vectors. Killing mosquitoes was the main method of eradicating malaria and filaria. So what they started doing, they started spraying DDT on this stagnant water bodies. So initially, uh, among the population of mosquitoes, maybe there were DDT resistant mosquitoes, but they did not have any selective advantage over the sensitive ones. Once DDT was used on a large scale, what happened? Only the resistant ones could survive. Those multiplied, and after a period of time, they became the major part of the population in such a way that now DDT was ineffective for mosquito control. So, in a population of mosquitoes where there were DDT resistant as well as sensitive mosquitoes, when the environment changed, when DDT started being used in the environment, the sensitive ones could not survive, but the resistant ones survived, multiplied, and became the major part of the population, again showing how nature selects only the fittest to survive. So here we have a mixed population of both resistant as well as sensitive mosquitoes. When DDT is sprayed, all the sensitive ones die. Who can survive? Only the resistant ones can survive. And you see after a time that the major population is now only the resistant mosquitoes. Another example is of sickle cell anemia. Now, sickle cell anemia is a fatal genetic disorder, and it is caused by a recessive mutation which causes sickling of the RBCs. That is, the normal hemoglobin, when present in the RBCs, make the RBCs a spherical shape. But abnormal hemoglobin caused by this recessive genetic mutation results in sickling of the RBCs. Now, these sickle-shaped RBCs have a reduced oxygen carrying capacity. They also break very easily, and this is the cause for this anemic condition in such a disorder. Now, since this is a genetic mutation, when you see, when it occurs in the homozygous condition, there is massive destruction of RBCs, and this person suffers from anemia, and there is early death of the patient. Whereas in the normal condition, the hemoglobin is normal, spherical, but in this normal condition, the malarial parasite which lives inside the RBCs is able to survive and thrive. So in areas, in places where malaria is prevalent, we see that though sickle cell anemia is a fatal genetic disorder, and in the homozygous condition can cause the death of the patient, in the heterozygous condition, the gene reduces the oxygen carrying capacity, but because of its sickle shape and absence of sufficient oxygen, the malarial parasite cannot survive inside the sickle cells. Such people with heterozygous gene for sickle cell anemia, they were protected against malaria. So though this is a fatal disorder, nature selected the heterozygous individuals and gave them resistance against malaria. So though in an environment when such a fatal disease will never be passed on to the next generation, this gene survived in the heterozygous condition because it protected the bearers of this heterozygous gene against malaria. So I've given you a picture of how normal cells look. See, round spherical cells, when they pass through blood vessels, they have no problem. But when you have sickle cells, sickle shaped cells, when they pass through these blood vessels, they block the vessels, they also break very easily. But you can see in Africa, there is a percentage of population where this sickle cell exists in the heterozygous condition. And why? Because such individuals are able to survive from infections such as malaria. So now we looked at the different examples of Darwin. Now there was a lot of criticism against Darwin, but there were again people who supported Darwin, and they were called the neo-Darwinists. And they proposed what is called the synthetic theory of evolution, or the modern synthesis of evolution. Now when Darwin was there, he did not know about Mendel or Mendel's work on factors that are inherited, so he was not able to explain a lot of his postulates. But now in the light of scientists uncovering the gene and about enzymes and one gene, one enzyme hypothesis, etc., neo-Darwinists try to explain Darwin's postulates as that organic evolution happens when there is a change in the gene frequencies. And how is this change brought about? By random mutation, and later nature selecting useful mutations. So organic evolution occurs by natural selection of genetically modified characteristics. There were two basic concepts of neo-Darwinists. According to them, the mutation is the one that generates this genetic variability, and in a population this genetic variability, when useful, is transferred to the next generation. So it is not the individual who possesses the variability, but the entire population. So according to neo-Darwinists, the unit of evolution is not the individual, but it is the population, and the gene pool of the population undergoes evolution and not just one individual organism. Such variations over a period of time leads to evolution and speciation. So according to neo-Darwinists, the major factors responsible for evolution are mutation, which brings about a new character, genetic combination, which combines favourable characters. Such favourable characters are selected by nature, and migration and hybridization also help in organic evolution. So with this we come to the end of Unit 4. I hope you understand what Lamarck's theory was, the different postulates of Lamarck, the criticisms that were raised against the theory proposed by Lamarck, and the scientists who supported Lamarck and tried to come up with explanations for Lamarck's theory. Then we talked about Darwin and his different postulates. We looked at certain criticisms against Darwin. We looked at 3 examples which prove Darwin's theory of natural selection, and we also talked about neo-Darwinism. So when you talk about Lamarck's theory, the main 2 points under Lamarck's theory is use and disuse theory and theory of inheritance of acquired characteristics. And when you talk about Darwin's theory, it is theory of natural selection and survival of the fittest. Now let me come back to our learning outcomes. You remember I asked you a question. Do you think Lamarck is right, or do you think Darwin is right? Now there is no right or wrong in this subject, because new discoveries are made almost every day, and what was an established theory maybe 10 years ago or 5 years ago, even 2 years ago, in the light of new evidence becomes completely wrong, and a new theory is probably put forth. So, do you agree with Lamarck, or do you agree with Darwin? Justify your answer. Thank you for listening to me. With this, we come to the end of Unit 4. Thank you.